Then number 20, they're asking us to find the value of x and y. We're going to find the value of x and the value of y, where 2x plus y plus I into bracket y minus 5 equal to 0. Remember, for the equality of complex numbers, for example, if I have equality of complex numbers, maybe like x plus yi, let me use the letters, m plus ni equal to a plus bi, for example. So for equality of complex numbers, if m plus ni equal to a plus bi, it means that m equal to n and m equal to a and n equal to b. That's what it means. So even here, I'm going to use the equality of complex numbers. This is 2x plus y plus I into bracket y minus 5 equal to 0 plus 0i, because here we have 0. So this is the complex number which is on the right hand side, on the left hand side, and this is the complex number which is on the right hand side. So mean that 2x plus y will be equal to 0, and y minus 5, coefficient of I equal to coefficient of I here, which is 0. So implies that y equal to what? Y will be equal to 5. If y is 5, what is the value of x? So to be 2x plus y equal to 0. So 2x plus 5 equal to 0, which implies that x is negative 5 over 2. So therefore, the point xy will be equal to, the value of x is negative 5 over 2, and the value of y is 5. I hope you're getting it very well. So thank you. Let us go to number 21, because number 20 is done. So now we are going to number 21. We are still on the revision questions about complex numbers. So number 21 is saying, find the quadratic equations that have the following roots. We have a, 21a. 1a, we have roots, there is alpha, which is negative 7i. And there is beta, which is 7i. So to find the quadratic equation, find the quadratic equation. Remember the quadratic equation, when you say quadratic equation, that is, I can say z squared minus sz plus p equal to 0. That's quadratic equation in form of sum and product, where S is sum of roots and P is product of roots. So now, how do we get sum? We just add. S is alpha plus beta, which is negative 7i plus 7i. The answer is 0. Product is the product of the roots alpha beta, which is negative 7i into bracket 7i. I hope you're getting what I'm doing. So now this is 49i squared, negative 49i squared. I squared is negative 1, that is 49. So this is the product. So bring this one in this formula. So it is z squared minus s. S is 0. So no need of writing it. 0, that's 0z plus 49 equal to 0. So the answer is z squared plus 49. So this is the required quadratic equation. Required quadratic equation. That's it. So we are done with A. Let's go to B. B, we have roots alpha equal to 2 minus 3i and beta 2 plus 3i. It is the same procedure. Our quadratic equation is z squared minus sz plus p equal to 0. So our s is alpha plus beta, which is 2 minus 3i plus 2 plus 3i. The answer is 4. Product, it is alpha beta, which is 2 minus 3i into bracket 2 plus 3i. So where this is a 4, we use, okay, we can expand 2 times 2, 4, 6i minus 6i, then negative 3i times 3i, negative 9i squared plus 9. You see the answer product is 13. So from product which is equal to 13, our quadratic equation is z squared minus 13z plus 4, which is equal to 0. So this is the required quadratic equation. That's the required what? Quadratic equation. Z squared minus 13z plus 4 equal to 0. So let's go to C, if you don't have any question about B. C, we have alpha, which is 1 plus 5i, and beta, which is 1 minus 5i. So with Z, we know that quadratic equation is in the form of sum and product. It is z squared minus sz plus p equal to 0. So our S will be alpha plus beta. Alpha plus beta, which is 1 plus 5i plus 1 minus 5i. The answer is 2. Then P, which is product, alpha beta, 1 plus 5i times 1 minus 5i, which is 1 plus 25. The answer is 26. So therefore, the required quadratic equation is z squared minus 26, minus 2z plus 26 equal to 0. So this is required quadratic equations. So we are done with number 21. I hope there is no any question. So let us proceed. Okay, we can proceed. We are on number 22. Find a complex number z satisfying the equation. We have z plus 4 equal to 3i z conjugate. Give your answer in the form of x plus yi, where x and y are real numbers. So now we have z plus 4, that is number 22, equal to 3i z conjugate. So we need z in the form of x plus yi. So we let z to be x plus yi. So mean that the z conjugate, it will be equal to x minus yi. So which means that x plus yi plus 4 will be equal to 3i into bracket x minus yi. So meaning that x plus 4 plus yi is the same as 3xi plus 3y, because 3i times yi, that is minus 3i squared, and I squared is negative 1, that's 3y. So we mean with x plus 4 plus yi equal to 3y plus 3xi. So we are going to use the equality of complex numbers, meaning that x plus 4 will be equal to 3y. 3x will be equal to y. So from there, y equals 3x. So it will be, we'll bring this equation into equation 1. It will be x plus 4 equal to 3 into bracket. The value of y is 3x. So now x plus 4 will be equal to 9x. So 9x minus x equal to 4. 8x equal to 4. X is 1 over 2. So if x is 1 over 2, we bring it here. So y will be 3 over 2. So therefore, our z is a half plus 3 over 2 I. So that is the answer. I hope there is no any question. Okay. So we can go to number 23. Number 23 is saying an electric circuit, the voltage where its unit is volts, current where its unit is ampere, and impedance where its unit is ohms are related by the equation. We have voltage equal to current times impedance. So the voltage in a particular circuit is 240 V, and the impedance is 48 plus 36I. Find the current. The formula is telling us that is number 22. We have voltage equal to current times impedance. You know that impedance is Z. So now the question is asking us the current when we are given V and impedance. So mean that our current must be equal to V divided by what? Impedance. So which means that what is our current? Our V equal to 240 volts. Our impedance equal to 48 plus 36I. So now what we're going to do, we're going to find the current. So our current will be equal to 240 divided by 48 plus 36I. So what does it mean? We do the conjugate. You know that if you have, when you have like Z1 over Z2 in a complex number, you know that it is Z1 times Z2 conjugate over Z2 times Z2 conjugate. We are going to use that formula. So this will be 240 into bracket 48 minus 36I divided by 48 plus 36 into bracket 48 minus 36I. This is 36 minus 36, okay. So which means that our current will be equal to 240 into bracket 48 minus 36I divided by, so this is 48 squared plus that's 6 squared. Because I squared, you know when you have like A plus B into bracket A minus B, the answer is A squared minus B squared. So I squared is -1, that -1 change this one to be positive. After getting that A plus B into bracket A minus B equal to A squared minus B squared, so let us proceed. Our current is going to become 240 into bracket 48 minus 36I divided by 48 squared is it is 2,304. Then 36 squared is 1,296. Then our current now is 240, 48 minus 6I divided by, when you add this, you get 3,600. We simplify. If we simplify by 4, by 0, 0, by 6, 4, by 6, we get 90 here. Then finally by 2, by 245 into bracket 48 minus 6I. Then when we reach here, we can divide by, we take, you see, when you take 45, when you take 45 divided by 5, we are getting 9. If we take 45 divided by 15, we are getting 3. So also here, you can take outside 3. You can divide by 3 here, and even by 3 here. Finally, you get 16 over 5 minus 12 over 5I, and this is ampere. So what was the question, what was the problem is just to take this one, 240, divided by 48 plus 36I. And what I've used here, we used what? The conjugate. So now the current that we have been they have been asking us is that one, which is ampere. 16 over 5 minus 12 over 5i. I hope there is no any question. We can proceed on number 24. So let's go to number 24. Number 24 is saying we have to solve the complex number where iz minus 2 equal to 4i minus z and put the answer in algebraic what? In algebraic form. I hope you have seen the number 24. The question is iz minus 2 equal to 4i minus z. We have to solve the value of z and you put the answer into algebraic form. So now the question is iz minus 2 equal to 4i minus z. So we're going to find the value of what? Of z. So we can bring this one there. It becomes z plus iz equal to 4i plus 2. We bring this one here. It was minus, now it becomes what? Positive. So we take z out of the bracket, comes 1 plus I into bracket z equal to 2. We can also take 2 out of the bracket to be 1 plus 2i. So now here, our z will be equal to 2 into bracket 1 plus 2i divided by 1 plus i. We use the conjugate property. So this is z equal to 2, 1 plus 2i times 1 minus I divided by 1 plus I into bracket 1 minus I. So this is z equal to 2 into bracket 1 times 1, that is 1, minus I plus 2i plus 2, because 2i squared negative 1 with this negative becomes positive, divided by this is 2. So this 2 cancels with that one, so our z will be equal to 1 plus 2, that is 3, negative I plus 2i, that is the I. So this is our answer. So that is the solution for number 24. I hope you have no any question. So let us proceed next time. May God bless you. Thank you.